that is of quantitative structure activity relationship. So in the last class we discussed what is called SAR. Basically, it is a kind of structure activity relationship that if I say that anyhow change in the structure if we are doing, the same changes will be reflected in biological activity. So that way, that is called the relationship between the structure and the activity of the compound. Then QSR and drug design, that we could identify that if we submit the properties of, if we submit some the chemical properties of the compounds and to the computer, then computer will able to allow us to predict those kinds of properties. We have also seen the history of QSR, started with the Mendeleev, and finally we concluded that any activity of the molecule, that is the property, or that can be the any kind of this structural property of the function of this property of a molecule, right? And these are all the kinds of other historical developments which occurred with the passage of time and the development of other tools. So as of now, the more present tools are 2D QSAR, 3D QSAR, and virtual screening and molecular docking, and so on. So among the QSR, then we started our discussion with this, that what is called a QSR. So it is a kind of relationship between the biological activity of the compound and its geometrical or physicochemical kind of the biological property of the system. So which can be, what are the uses? The uses can be that it is useful to predict the activity of unknown compound or a new compound. Without synthesizing the compound, we can predict the activity of the compound. Right? Just like the जैसे कोई ज्योतिष है वो भविष्य में क्या होगा वो बताता है. So similarly, QSAR can be used for shortlist the compounds. If we have large library of the compounds and we want to select any of compound, that which compound is going to react or which compound is going to be more active, then this kind of technique can be used. Three types of the quantitative relationships depending upon whether the structure is compared with activity, property, toxicity, can be classified respectively as QSAR, PR, and TR: activity relationship, property relationship, and toxicity. Varieties of the descriptors, such as introduction. In the introduction, we have seen all these descriptors. In our coming slides, we will be discussing all these parameters in depth to understand that how a descriptor can be correlated with activity. What is the meaning of descriptor? Descriptor का meaning यही होता है कि it is going to describe the property of the molecule, और उसी property को describe करने वाले parameter को बोलते हैं descriptor. So we have seen these two examples, and we could understand that just by giving a suitable example of a basketball team. That if we want to constitute a good basketball team, and these are some of the parameters which have been enlisted here, and that mean that these are the parameters which should have be present in the candidate in more or less extent. And we could see that some of the parameters which we can calculate as well as some of the parameters which we cannot calculate. For example, I can measure the speed. I ask candidates to have a running race of 100 meter, 500 meter, and I can estimate this parameter. I can calculate this parameter, what is called. But I cannot calculate the passion for the game, because it is not a calculatable parameter. It is not a quantifiable one, a qualitative parameter. So in this context, whenever QSR is there, so my point is to say is QSR will deal only with quantifiable parameters. Parameters which are not quantifiable are useless for QSR, cannot be used in QSR. A person with high IQ, I give this example just to illustrate or demonstrate that while the selection of QSAR, we should select uh, proper parameter. Because what will happen if we go on working with wrong parameter, then we will end up in false positive results or in wrong development of QSAR, right? जैसे IQ cannot be correlated with the height and long limbs of the persons. IQ can be correlated with probably size of the brain, right? So this is one of the danger that we should keep in mind. It is a kind of alert that whenever we are selecting the parameters, specific that the parameters must be correlated with the biological development. So up to this time we have seen, and this was the slide which we have start our next discussion. So these are the types of the QSR which are you can see on your screen, that 1D QSR, 2D QSR, 3D QSR, 4D QSR. Okay. Now in this context, the most suitable kind of the QSR is 1D QSR. So as the name suggests 1D, so D stands for the dimension. If I basically if I go to the mathematic point of view, and if I say what is the dimension, so in one dimension, uh, what is this? If I draw something on a space, so it is just like a point, right? So a point is a one dimensional parameter. According to mathematics, point is basically undefinable terminology. We cannot define the point. Okay, so this is the point, and it is unit parameter, one dimensional, unidimensional. Uh, if I draw another point, right? So there are 2 points on the board. Now, if I try to connect them, so trying to connect them to a single line will make this line as a two-dimensional parameter, right? Now, what are the two-dimensional? Their line has certain length, and this line has certain breadth. Okay, so this is two-dimensional length, breadth, લંબાઈ અને પહોળાઈ જેને આપણે કહીએ. So it is a two-dimensional parameter. Then if I draw another point, if I point out here, and then I try to connect these two dots, so what will happen? I will have another angle. Angle I have more about it is 90-degree angle. So we will say that again two-dimensional parameter. Suppose we can have although a new quantity is there, but two lines are constituted with each other. So it is okay. Now if I try to connect these two dots, so connection of these two dots together, that will lead to the formation of a particular shape. And what is that shape? Shape is triangle. Triangle is also a two-dimensional parameter because still I am working on a 2D platform, a 2D board, right? But instead of showing you people, if I show that this is a triangle which is having certain, I am not able to draw them properly. I see that they are connected with each other likewise. Their shape is there. Trying to draw their shapes. And you see the triangle which is made up of three faces. Ideally, there are four faces. Two are in front of you, one at the back, and one face at the bottom. So this is a basically three-dimensional diagram. So we started from the point, then it become a line, then it become an angle, then it become a shape, and now that shape has been converted into certain object. आपको समझ में आ रहा है वन डायमेंशनल क्या होता है, टू डायमेंशन क्या होता है, थ्री डायमेंशन का मतलब क्या है, राइट? एंड फोर्थ डायमेंशन, that is what different literature is used to tell that fourth dimension is the time. फिफ्थ डायमेंशन, जैसे टाइम का मतलब क्या होता है, जैसे फोर्थ डायमेंशन है, So at T1 is equal to as T is equal to T1, certain object is having X, Y, Y1 and Z1. At T2, the objects are having coordinates like X2, Y2 and Z. What is the difference in X1, X2, Y1, Y2 and Z1, Z? So this is considered as fourth dimension. And fifth dimension, there is, it is further advanced that it has been considered as a space or in આપણે ગુજરાતીમાં કહીએ તો અવકાશ. Space is also considered in the fifth dimension. So point to what is the meaning? Meaning is to say that as we move from one dimension to two dimension to three dimension, hierarchy of the system advances. System becomes complex. So similarly, that same thing I have discussed these dimensions 1D, 2D, 3D in general term aspects. One dimension is dot, line, angle, shape. Sorry, one dimension is only a point. Two dimension is a line, angle, shape. These are two dimension. Three dimension can be an object which is having length, breadth, and depth. લંબાઈ, પહોળાઈ અને ઊંચાઈ ત્રણેય three dimension હોય. And fourth, that is time. Fifth, that is fifth one, that will be space, right? So these are the general aspects, but in terms of the QSAR, so we can have 1D parameters, which are simplest parameters, PK and not. They are considered as 1D parameters. 2D parameters, we will also see their examples. So 2D is basically this deals with the 2D structure of a molecule. So whatever the structures you have drawn till now in your CamDraw or in your notebook, all those are 2D structures, because you are not talking about what is the how the groups are oriented in a three-dimensional space. That is what called a structural 2D structural pattern. That is can be correlated with three-dimensional. That is basically deals with the three-dimensional structure of the model. Most of you have installed the CamDraw. So if you open up, there is different kind of CamDraw is there. What is called 3D Cam BioDraw. You open that structure. If you open that software, then you will be able to draw the molecules in their three dimensions. Just like methane, which is tetrahedral in nature. So you can draw, instead of drawing CH4s, four total lines, you can draw the methane molecule in a three dimension. So whatever the properties which are correlated with three-dimensional structure of the molecules, they are considering. So up till now, we will be studying in our articles QSAR and QSAR. These are the basic model of. Other are the highly advanced models. For the sake of simplicity, you can remember that 4D QSAR deals with the representation of the ligand. 5D QSAR deals with the somehow use fit scenarios in the ligands, and 6D QSAR that represents solution. These are the higher advanced models with the solvent whatsoever there. So I hope that I'm able to make you people aware about the different, but it's not necessary that 2D QSR is always superior than 1D QSR, or 6D QSR is always superior than 3D, right? तो ऐसा जरूरी नहीं है कि जैसे I have mentioned in this sentence that no claim is valid to state whether a correlation developed by the descriptors pattern, right? 1D QSR अपनी जगह पे सही है, 2D QSR अपनी जगह पे सही है, or 60 QSR is also right at its own merit. Okay. So this we should keep in mind that 1D, 2D, 3D, 4D, 5D, and 6D, all the kinds of QSR are appropriate at their own, are good at their own correlations, but there shall be no any kind of superiority in between. But we should keep this in mind that whenever we are developing a QSR, should be applicable to common structural class of the compounds. जैसे कि if the compounds, if we are developing the QSAR of all the quinoline ligands, so whatsoever the ligands are present in QSAR, that should be quinolines. Adam has taught you anti-malarial compounds, so we know the meaning of what is called quinoline. We are developing such QSAR, तो उसमें सारे जो structures है वो quinoline के ही होने चाहिए. Or instead of that, if we add, let us say, some 3-membered cyclic ring or 4-membered cyclic ring or 5-membered cyclic ring, it will not be useful to predict the activity of this compound, such as 3-membered, 5-membered, 4-membered compounds using the QSAR model developed by 6-membered compounds. Right? This is more important. कि QSAR में जो भी स्ट्रक्चर्स हम यूज करते हैं वो एक जैसे सेम ही होने चाहिए. 6-membered ring, similar heterocycles, not the dissimilar heterocycles. कोई एक चीज कॉमन होनी चाहिए. So that we will also learn when we will be developing. Okay, जो ना अभी जो मैंने आपसे बात की, these are the dimensional descriptors, dimensional QSAR. So what this dimensional QSARs are exactly? So if I say, for the sake of simplicity, zero dimensional descriptors. Zero dimension मैंने क्या बोला? Zero dimension में मैंने बोला just dot. Molecule को as a dot क्या represent कर सकते हैं? So molecule को हम as a dot represent कर सकते हैं as a form of atom. So then we can count that likewise here, that how many numbers of atoms are present in a molecule, how many bonds are present, how many what is the molecular weight, the atomic properties, of additive atomic properties, chemical formula, etc. They have been listed over here, such as molecular weight. If I say molecular weight of benzene, so around 78, molecular weight of water, 18, ammonia. So it is, all these are zero-dimensional descriptors. They will follow under zero-dimensional descriptors. Hydrogen atoms, carbon atoms, heteroatoms such as nitrogen, number of oxygen atoms such as phenol. If I say a number of oxygen atoms in phenol, it is only 1. But if I say a number of non-hydrogen atoms in phenol, so except the hydrogen atoms, I will have to consider there are 6 and 7 atoms, 6 carbon atoms and 1 oxygen. So there are 7 non-hydrogen atoms. How many double bonds? How many triple bonds in a particular structure? So वो भी unit number ही मिलेगा, integral number. So that is also considered as a Let me give you the examples of paracetamol. How many aromatic bonds are present in paracetamol? So we can say, sir, there are 6 aromatic bonds which are present in paracetamol. How many, whether paracetamol is a 6-membered ring, so or 4-membered ring. So again, the answer will be integral number 6, that paracetamol possesses 6 rings such as benzene. So all these kinds of descriptors are considered, and as rightly said in our initial slide, that we can correlate various log P, etc. Then one-dimensional descriptor. So as the name suggests, one-dimensional. So here we have to see that what can be one-dimensional descriptors. Now here a one-dimensional descriptor को उसको बोलते हैं कि जिसमें fragment carbon किया है. How many number of primary carbons, secondary carbon, tertiary carbon, quaternary, they are considered into this. They say what is called primary carbon. So you know the structure of methanol. So there is only one carbon, but it is either primary, it is only methyl carbon. But you know the structure of ethanol. So there are two carbons, CH3, CH2OH. Okay? So your CH2 carbon is called primary carbon because it is connected with other carbon. And similarly, we can also classify this kind of tertiary carbon in tertiary butanol. So if I draw the structure of tertiary butanol, so butanol tertiary butanol का structure होता है, it is like, I'm not drawing CH, I'm not writing CH3 CH3, but this is one of the popular way of writing any structure. That if I'm not mentioning at the terminal of a bond, at the end of a bond, if I'm not mentioning CH3, uh, chemist will understand that here a methyl group is present. So this is the structure of tertiary butanol. So what is it possesses three methyl groups, and this carbon which is here. So this carbon is basically tertiary carbon. As the central carbon is connected with three different oxygen or three different carbon atoms. इसलिए जो टर्शरी ब्यूटेनॉल में जो कार्बन है उसको बोलते हैं सॉरी टर्शरी कार्बन. Okay, so I hope that I am able to make it clear. Hello. I hope that I am able to make you people clear about the tertiary carbon which is present. So if I say how many tertiary carbons are present in the structure of paracetamol, the answer will be 0 because tertiary carbon paracetamol. Then these are other parameters, so I will not go into the depth, but this we have also encountered number of hydrogen bond donors in our Lipinski filters when we have seen that what can be here there are number of hydrogen bonds. We have seen that hydrogen bond donors, number of hydrogen bond acceptors. Okay. So since this is a class, so let me explain you hydrogen bond donor किसको बोलते हैं, hydrogen bond acceptor किसको बोलते हैं. The same structure of butanol I can explain. It possesses this hydrogen also as well as this oxygen. But this oxygen which is there, so that possesses two lone pairs. So on the head of the oxygen, there are two lone pairs. I am keeping it is a different color, so you can see lone pairs which are present on oxygen. There are not only one lone pair, but there are two lone pairs. So I am highlighting other pair. There are two lone pairs on the head of the oxygen. So now how do we decide that the tertiary butanol के पास oxygen भी है, hydrogen भी है. So which is hydrogen bond donor and which one is hydrogen bond acceptor? दोनों हाइड्रोजन बॉन्ड बनाता है, ऑक्सीजन भी हाइड्रोजन बॉन्ड बनाता है, हाइड्रोजन भी हाइड्रोजन बॉन्ड बनाता है with another molecule of tertiary butanol. Question is which is hydrogen bond, which atom is hydrogen bond. तो याद रखो जो हाइड्रोजन बॉन्ड डोनर होता है वो हमेशा इलेक्ट्रॉन एक्सेप्ट करता है और जो हाइड्रोजन बॉन्ड एक्सेप्टर होता है वो हमेशा इलेक्ट्रॉन डोनेट करता है. राइट, सिंपल फिलोसॉफी. डोनर है HB डोनर विल एक्सेप्ट, the acceptor will donate. With this philosophy, so in this oxygen is the atom which possesses two lone pairs, so it is going to I will use a different color to highlight हाइड्रोजन बिकॉज उसके बाद जो हाइड्रोजन बॉन्ड वो बनाएगा so that hydrogen bond of other atom like this है ये भी हाइड्रोजन में आपको दिखा रहा हूँ समझो कि टर्शरी ब्यूटेनॉल के साथ not able to draw with the help of my cursor but आप समझ जाओ कि what is the message है तो ये जो हाइड्रोजन बॉन्ड बना है बिटवीन टू टर्शरी ब्यूटेनॉल्स सो इसमें जो ऑक्सीजन है वो दूसरे वाले हाइड्रोजन से दूसरे वाले टर्शरी ब्यूटेनॉल से हाइड्रोजन एक्सेप्ट करता है इसलिए ये इलेक्ट्रॉन डोनर है बट दिस इलेक्ट्रॉन डोनर विल बिकम हाइड्रोजन बॉन्ड ये रूल है कि जो हाइड्रोजन बॉन्ड डोनर होता है वो हमेशा इलेक्ट्रॉन एक्सेप्ट करता है उस हिसाब से ये ऑक्सीजन विल बिकम hydrogen bond acceptor because it is donating the electron and this hydrogen here is there that is so this hydrogen and showing an arrow I am discussing that hydrogen this hydrogen is accepting the lone pair so जो electron accept करता है वो hydrogen bond donor होता है so in this case this will become hydrogen bond acceptor as a hydrogen bond acceptor and this lone pair which are oxygen atom which is present there that is D I am labeling it as D so it is not as the same thing which I have also discussed in our meetings practicals when I use explain what is called hydrogen bond donor what is called hydrogen bond acceptor. Okay so tertiary butanol में कितने hydrogen bond donor है answer is what is the answer who will tell me our how many hydrogen bond donors are there in tertiary butanol are you there Bhavar are muted okay Jill am I audible to you Jill okay any other from the class how many hydrogen bond donors tertiary butanol you can text your answer if your mic is not working one or two or you don't know the answer two it's not correct there is only one hydrogen bond donor yes Diti has rightly said there is only one hydrogen bond donor that is oxygen atom there is only one hydrogen bond acceptor that is hydrogen atom yeah. So number of hydrogen bond donors and acceptors alag alag. Similarly you can also remember the structure of aspirin vinyl ring which is having OH and OC double OCH है तो जितने नंबर ऑफ OH और NH होते हैं वो आपके कंसीडर किए जाते हैं और हाइड्रोजन बॉन्ड और हाइड्रोजन बॉन्ड एक्सेप्टर्स जितने भी आपके H है which are connected with electronegative atoms and you consider hydrogen bond okay so ये आप कैलकुलेट भी ऐसे भी कैलकुलेट कर सकते हो looking at a structure of a parameter or else we have also calculated our mole inspiration engine that is what called okay? और बाकी भी सब पैरामीटर है जैसे molecular refractivity or refractive index etc so that can be also considered okay. So now I am coming back to this 2D descriptors so So other topological descriptors are considered for this, such as text. I will not go into the depth of it, but just I want to say topology. Topology may meaningful as a uh, shape of the molecule. So what is the shape of the molecules? So that can be considered 3D descriptors. So basically 3D descriptors which deals with the three-dimensional shape of the molecule. जैसे three-dimensional shape क्या है जैसे कि what is the van der Waals surface area, solvent accessible surface area, polar surface area, non-polar surface area, hydrophilic, hydrophobic surface area. All other kinds of parameters are discussed. Then homo-lumo potential energies, energy differences, active conformation, global minimum that are also considered. Now here I will highlight this terminology, what is called conformation. Although other parameters are you have not studied, such as surface area, but I think you people have studied surface properties such as underline confirmation. What is called confirmation? You have visited this N-butane, and then you identified some of the conformations such as eclipse. Some of the conformations are partially eclipse, fully eclipse, gauche, and staggered, anti. So all those kinds of the structures which we can derive by the rotation across the carbon-carbon single bond. All of them are called as conformations, right? So uh, उसमें से भी all of them are the conformations of butane. Which is more stable conformation? Let me tell you, that is staggered or anti. So staggered and anti conformations are termed as global minimum conformation, whereas other conformations are called as active conformations. And so that we will see in the class also. What are the different kinds of conformations? And other parameters are there such as ionization. So I am discussing only those parameters which you have visited previously, so that we can understand what are the various descriptors which are going to describe the molecules, and with this discussion we can understand yeah, this is another kind of a descriptor which are called global descriptors and local descriptors. तो ग्लोबल का मतलब वही होता है कि these are the descriptors for the entire molecule. उसी को बोलते हैं global descriptor, just like dipole moment. And if I say dipole moment, so dipole moment is applicable not to the let me, if I say hydroxy bond, hydroxy functional group of aspirin, but dipole moment is applicable for whole molecule. Dipole moment is applicable for whole water molecule, whole NH3 ammonia molecule. अकेले NH की dipole bond dipole moment नहीं होती, the dipole moment of ammonia. जैसे a simple example we have learned in organic chemistry. Again, I am highlighting to introduce you people about the dipole moment. Jैसे you have visited dipole moment, that there are certain molecules which possess null dipole moment. Okay. So one of the molecule for this is carbon dioxide. This is the molecule which is zero dipole moment. Why? Because dipole moment for which will can be always represented by such kind of the arrow from non-electronegative atoms. Okay. So if I say the dipole moment of CO bond, that is in this direction, but for other bond, this dipole moment is in such direction. So this is, if I say this is plus, this is minus, so overall both the becomes negative. Oh, sorry, overall both the becomes 0, plus or minus equal to 0. So there are many other molecules which possess zero dipole moment, PCl4, methane, etc. So just I take somehow your time to explain you what is the meaning of dipole moment. Refractive index. This is the one of the useful parameter. I think Dr. Bodiwala might be discussing this parameter uh, class when he is asking what is called reflection, what is called refraction, and other such as transmission, absorption, etc. Okay. So what is called refraction? Just say we, if there is a certain uh, that is, if we have certain a vessel, or let me tell you certain kind of beaker is there which is full up of certain liquids, or a little bit or certain मानो कि कोई vessel है और it is fill up of certain liquids. I am drawing the dashed lines. That is, you have to image it as a vessel fill up of certain liquid solution. Okay. So and there is a certain you can assume a source of a light such as sun. So this is sun, which is also considered as a uh, source, or it can be a sodium lamp also, which is a source of the light. If the lights are coming from the sun, then what will happen? This radiation which is coming from air to liquid, so that will not go by straight fashion like this. जैसे वो आ रहा था वैसे ही वो आगे नहीं जाएगा उसी डायरेक्शन में, but it will we have certain bending. Likewise, it may go in this direction. And when it will come out from the water, or let me say liquid, to the air, then उसी direction में वो नहीं जाएगा. Instead of that, it may go to some other direction. Likewise, this. So this is what something called change in the angle of or change in the angle of the light. This phenomena is termed as refraction. Okay, so these are the all refractive index, which is we will also calculate this refractive index in our one of the practical using one of the instrument what is called APS refractometer. So we will be visiting at time APS refractometer. Then another parameter what is called local descriptors. So global descriptor का मतलब होता है कि they are going to describe the total molecule, the entire molecule. And local descriptors का मतलब होता है they are going to describe only a portion of the molecule. जैसे pK, that is a local descriptor. जैसे क्योंकि जैसे if I say benzoic acid, so benzoic acid की acidity, that is because of carboxylic acid, not because of the benzene ring. Okay, so it is called as local descriptors. Hydrogen bond donors and again acceptors, these are the local descriptors. Suppose if I say how many hydrogen bond donors are present in tertiary butanol, so that is related with OH, not related with the tertiary butyl group. These are the descriptors which are going to describe the local portion of the molecule, local fragment of the molecule, और जो प्रॉपर्टी ऐसे वो डिस्क्राइब करते हैं उसको बोलते हैं local descriptor. Okay. So another kinds of the molecular descriptors is we will be visiting in our coming slides. Electronic descriptors such as this, which is basically Hammett constant and ionization constant. Friends, these electronic parameters in which we are going to discuss what is called Hammett constant. So I will come to that. So it has been given by a scientist as we discussed in one of the slides of history that Hammett has termed this terminology sigma, that is called as Hammett constant. So we will be visiting exhibiting these parameters in our slides. Just today we will discuss that. Steric parameter. So these are the steric parameter: molar refractivity, van der Waals radius, molecular, molar volume, upstream parameter. This is important parameter which is devised by the scientist staff. उसी के नाम से ये पैरामीटर is popular as TAF's steric parameter. We will also visit this TAF's steric parameter, how it is calculated, what is the formula, so that we will see. And all these are hydrophobic parameters. Now, why we require hydrophobicity? Most of the membranes, most of the compartments of our body, they are made up of lipid. And if a drug molecule want to cross the lipoidal cell membrane, then according to the principle of like dissolves like, molecule should possess sufficient amount of lipophilicity. Lipophilicity का मतलब है lipid loving, will be easily soluble in lipid. और hydrophobicity, so hydrophobicity and lipophilicity both are same. Because जो लिपिड में सॉल्युबल होता है, जो ऑयल में सॉल्युबल होता है, वो वाटर में इनसॉल्युबल होता है, राइट? सो लिपोइडल लिपोफिलिक सब्सटेंस आर आल्सो टर्म एज हाइड्रोफोबिक, वाटर रिपेलेंट, वाटर हेटिंग और insoluble in water. So this way, these parameters are hydrophobic fragmental constant, solubility parameter, and distribution coefficient, also called as partition coefficient. So log P, which we will determine in one of your practical using somehow solutions, and already you have calculated log P using the theoretical calculations. Remember, then CAMDRO is also helpful to calculate log P, and also you could calculate log P using theoretical calculation भी हो सकता है, और प्रैक्टिकल भी हम लैब में जाके सॉल्युबिलिटी को चेक कर सकते हैं कि कोई ड्रग है वो वाटर में कितनी सॉल्युबल है एंड ऑक्टेनॉल में कितनी सॉल्युबल है, और वो सॉल्युबिलिटी का रेशियो लेके हम जब उसका लॉगरिथम लेते हैं. So these are three parameters: hydrophobic, steric and electron. Steric की जब बात होती है तो steric parameters can be correlated with the bulkiness of the molecule, the size, bigger size of the molecule. How to understand steric or bulkiness? जैसे methanol, if we compare methanol CH3OH versus tertiary butanol, तो मिथेनॉल में तो एक ही कार्बन है और बहुत ही छोटा मॉलिक्यूल है, लेकिन टर्शियरी ब्यूटेनॉल में 4 कार्बन है और बहुत रिलेटिवली बहुत बड़ा मॉलिक्यूल है. आई कैन नॉट से टर्शियरी ब्यूटेनॉल इज द बिगेस्ट मॉलिक्यूल, राइट? बिकॉज़ देयर इज समथिंग कॉल्ड रिलेटिविटी बिटवीन दिस टू टर्शियरी ब्यूटेनॉल एंड, राइट? सो दीस आर द अदर quantum chemical descriptors. Quantum chemistry is one of the chemistry, because now I will ask you to go back, I think, or perhaps Dr. Bodiwala might have taught you this thing, that the nature of the light, which is devised by some different scientists. So or you people have also learned during your schooling that uh, uh, the principle of the de Broglie and the principle of Max Planck, and also the claiming of Schrodinger about the nature of the light, whether it is having wave property or whether it is having a matter property. Two different types of the different principles have been. De Broglie have said that it is having somehow kind of matter property. Max Planck has said that light is having wave property, and Schrodinger or some other, I don't remember exactly, maybe Schrodinger or other gentleman, who has told that light is consist of both the types of properties, matter as well as wave property, and that is what called as dual property of the light. So all these kinds of concepts are basically studied in क्वांटम केमिस्ट्री। क्वांटम का मीनिंग होता है किसी भी फ्रेगमेंट का सबसे छोटा पार्ट, राइट? जैसे इफ आई से दैट अ मॉलिक्यूल is water, so water is made up of, we will say molecule is made up of atoms. Atoms are made up of proton, electron, neutron. Okay? Then protons, electrons, neutrons are made up of, then these proton, electrons and neutrons are made up of certain particles. So what these particles are, this kind of minute level of study is carried out in under the scope of quantum chemistry, and where this atomic net charge, the energy of highest occupied orbital E HOMO, and energy of lowest unoccupied molecular orbital are considered. तो ये होमो लूमो concept, where it has come? Homo and lumo concept basically they came when you have studied this. I do not perhaps in your first year organic chemistry. MD, I have organic chemistry in that class. And different kinds of this energy phases or butadiene. Right? उसमें we can easily study Diels-Alder reaction. What is called HOMO, what is called LUMO. Apart from this butadiene, 1,3-butadiene, we can also study the same thing, HOMO and LUMO, or benzene also. This is very nicely given in the organic chemistry by Morrison and Paul. What is called HOMO. All these parameters are again considered as quantum, right? And another parameter, the last kind of the parameter, which is called spatial descriptor. This is not related with SPECIAL. स्पेशियल, स्पेशियल का मतलब होता है इज डिराइव फ्रॉम द स्पेस, डिराइव फ्रॉम द सर्टेन, so that is called radius of the gyration. We will be learning NMR, or I do not know whether अभी तो आपका एनालिसिस की शुरुआत ही हुई है। जब आप NMR जब सीखोगे तब आप learning that each and every nuclei is rotating around its axis and with a certain speed. So it is creating somehow magnet, and that magnetism allows the gyration. So this kind of properties can be calculated using software, or also called as gyromagnetic ratio. Dr. Podiwala teach you this parameter very easily, or very elaborate this parameter when he will be nuclear magnetic resonance NMR spectroscopy. तो उसमें आपके दोनों पैरामीटर you will be visiting there. So this molecular descriptors are used. Some of the parameters we will be calculating in the practical, such as molar refractivity and log P. I think we will very start learning this. Parallel, it should go on hands. में भी जो आपको सीखने को मिल रहा है, same thing you should be also that way, hand on hands and soft exercise you should have. And after this, we have seen all these parameters, and this is more important. I will be stopping after this slide. Here, I want to discuss with you regarding the analysis which is proposed by this student. One of the parameter approach that has been given by the scientist Corwin Hans. So, Corwin Hans के नाम से parameter is called as Hans analysis. Okay. And another scientist, there are two scientists, Free, first person is Free and other is Wilson. So, जैसे फ्री विल्सन अप्रोच जब हम लिखते हैं तो हम ऐसा लिखते हैं कि फ्री विल्सन, but in fact it is not only one person, they are the two persons. So टू पर्सन्स ने ये जो लिखा अप्रोच जो किया कहा दैट अप्रोच इज कॉल्ड एज फ्री विल्सन एंड उसी के नाम से two approaches are there. We will be learning these two approaches in depth. That what is called Hans analysis, which has been proposed and a linear kind of approach. Other kind of approach is non-linear approach. Now, what is the meaning of linear approach? Let's say if I show a certain kind of diagram, so if I draw this x and y axis, and if this is a certain, this is the observed trend of particular y parameter with x. Okay. So this is the trend line. Trend line means how the x is correlated with the y. So in this way, this y is correlated with the x. How is that? Their relationship is a linear. जितना x में इंक्रीमेंट होता है उतना ही इंक्रीमेंट y में होता है. जितना डिक्रीज x पैरामीटर में होता है, the similar kind of decrease is going to happen for y as well. दूसरा एक अप्रोच है जिसको बोलते हैं नॉन लीनियर अप्रोच. तो नॉन लीनियर अप्रोच का जैसे इक्वेशन जो आपकी उस पे है, that equation I am drawing with the help of another non-linear approach. So this kind of approach, which is for correlationship of something x parameter with some, sorry, that point, which is y. So this kind of correlationship between like this. तो यहाँ पर जो है ये आपका linear approach है. So this is the demonstration of linear approach, and this one will be the demonstration of you can see this is a lined one, x versus y, that is a kind of linear approach, and this is non-linear क्योंकि थोड़ी देर तक तो linear था, फिर एकदम मैक्सिमम वैल्यू बन गया और इसके बाद ये डिक्रीज हो गया. मतलब x में यहाँ तक जहाँ जैसे x में इंक्रीज होता गया वहां तक भी y में इंक्रीज था. up to this point x was at this value of x, y was maximum, but after this point of x, this y has suddenly dropped. Okay, so this approach is called as non-linear approach. और उनका इक्वेशन क्या है? So you can see that equation is like this: log 1 upon c. This is Hans analysis. There are two models for this. One is called linear model, other is called non-linear. Then फ्री विल्सन अप्रोच. तो जो भी लिमिटेशन यहाँ पर Hans एनालिसिस में थी, तो सेम limitations have been covered by free Wilson approach. So, free Wilson, he has considered not only one parameter but whatsoever the number of the parameters, n number of parameters have been considered. So we will learn both of these models in our coming classes. So here we will be stopping for ourselves. I will restrict myself from this slide, and we will try to learn something additional from this onwards, and how Hans analysis and free Wilson analysis, two types of the basics models are widely used kind of two-dimensional quantitative structure activity. Okay. So if you have any doubts, you can ask, because I think we have a couple of minutes with us, so we can discuss. Is there any question?